Alright everybody, we are talking about the Mass and Change lab. Hopefully, Mass and Change lab. Hopefully we got done with all of the steel wool stuff and we are finally onto the sugar and alkaseltzer portions of the lab. Now, some of you got further than others in terms of the sugar section, but I know none of us got to the alkaseltzer section, so you better pay attention to that part because there's going to be some interesting thoughts about that, maybe, I hope. So, for the sugar, what I did here, I just kind of made up some data because I couldn't very well have one video and 6 different classes and have everyone's data showing. So I just made up a few different examples. So the first one with the sugar, we see we obviously have no change in mass from the before to the after. The second one, we have a reduction in mass by about 8/100ths. And then the last one, we have an increase in mass by a little over 2.5 grams. So we're going to take a look at each one of those and what that looks like. Again, some of you in class, we actually talked about these already. Some of you we didn't. So here we go. I suppose if you want to fast forward, you can through parts or whatever. I don't really care. So let's see. So we're starting with the first one. If the mass is the same before and after. Well, first of all, what should the particle diagram even look like for, say, the sugar and the water situation here? So here's what I'm going to do, which I believe I did in class. I'm going to say 1, 2, 3, 4. Oops, those don't look like particles. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh boy, yeah, we'll stop at 15 because I can. So 15 particles of what? Well, the blue one we're going to say is water. Gosh, writing on this screen is terrible. It's just terrible. Oh my gosh, that's supposed to, oh my gosh, that's supposed to be a dash. All right, so that's a water particle, and I have 15 of them in there. And what else should I have in my little diagram? Well, if you remember correctly, in the lid you put some sugar particles. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I put 10 sugar particles in the lid. So all of that stuff should have been on the balance, on the scale. The vial, the water in the vial, the cap, and the sugar in the cap. All of those things would have been massed before. Oh, hold on, I better add to my key here. And I got to have sugar down here. Sugar, particles. All right, wow, the writing's awful here. You have to make do with what it is. I can't help it. I'm sorry. Oh gosh, where was I? I don't even know. All right, so I have my sugar particles and I have my water particles. Now, according to the data, you have no change. Now, how do you explain that? I'm hoping that if your mass did not change for the sugar, that you said, hey, that means we have all the same stuff afterward that we had before. And then, if you say that, I suppose you'd be right. Which means, in our after part, we need to make sure we have how many water particles? 15, which is what I said. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 water particles. And we still have our 10 sugar particles because you moved them from the cap into the vial. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So at this point, if you think about it, and then you look at what's going on here, we have the same exact mass before and after. We have 15 water particles here, 15 water particles here. We have 10 sugar particles here, we have 10 sugar particles here. That indicates that our mass has not changed. Everything we started with, we have ended with. All right, moving on. Oh boy. So now, we have second scenario there of the water and sugar situation where we lost mass. The mass went down by about 8/100ths. So how are we gonna show that? Well, just like we did before, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Aren't you glad I can count? 11, 12, 13, 14, 15. 15 water particles. And 1, 2, oh my gosh, that's terrible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 water or sugar. Oh my gosh. That's the water, that's the sugar. All right, so how are you going to explain that your mass went down from here, the before, to here, the after? Now, I believe we had some discussion on that already. One group I know in one of the classes actually spilled water out of the vial. Terrible. You should be ashamed of yourself. Some people mentioned to me that they spilled sugar when pouring the sugar into the vial, that not all of the sugar made it into the vial. You all should make paper funnels. They work well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 water particles, and I haven't transferred all of my sugar particles into the vial. So I'm going to have 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. Meaning I spilled some sugar. Some of it did not make it into the vial. I have fewer particles here than I have here. The after has less than the before. And I'm showing that, demonstrating that, by showing you that I have some particles that have not made their way into the, what's that called, vial. Oh my gosh, next. Okay. Last one. Now, this one we had 49.44 grams initially in the before, and then we ended up with 52.06 grams after. That's an increase of like over 2.5 grams there, peeps. So how would your mass have gone up by 2.5 grams? Oh, I had some theories, and I know maybe a couple of the classes I think we had something like this happen. And so here we go, people. I'm not counting out loud. I think there's 15 still. So here's my theory. 4, 5, oh, so I can see I can't do it without counting out loud. 7, 8, 9, and 10. So I have 10 sugar particles in the cap. I have 15 sugar particles in the vial. We all know there's billions and billions of those particles, and I'm just representing them with a few because it's quick and easy to draw. Now, how do you go from having this much mass to having this much mass after you've combined them? Well, I'll tell you. Hold on. Oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here's what happened. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my theory, all right? You all, whoever you are, and you know who you are, you groups, you never measured that. If you went up by about 2.5 grams or so here, from the before to the after, the cap itself has a mass of 1.7 grams. 1.7 grams. The sugar is another 0.5 gram-ish. I'd say 0.5 to 1 gram. So what does that translate into? That translates into about a 2.5 gram jump from here to here because you'd never massed this part. Jeez, come on, people. All right, I think that's it. On. Oh my gosh. This is one of the alkaseltzer ones. Now, if you had noticed, I don't know if you did or not, almost everyone in the class had, well, almost everyone in all 6 of my classes had the mass go down. Mass went down for the alkaseltzer. Now, we haven't had any discussion on this yet. Oh crap, I didn't put a water level. Water level water level. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I have 15 particles there. I have 1, 2, oh boy, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 particles there of water. Oh boy, I need a key. I guess I should have made a key every time. Now, in terms of the alka-seltzer tablet, I guess I could draw a little pie wedge here, a little triangle. So I got my little triangle. Oh, that's not good. Hold on. Oh my gosh, it's not even a triangle. Okay, there's my triangle. There's my pie wedge. And I need some alka-seltzer particles, so I'll say 1, 2, 3, 4, 5, 6, 7, 8. I guess we'll stop at 8. Now, that's before, and that gives you this mass right here. All right, oh shoot. Alka-seltzer. All right, so I have, oh my gosh. Oh jeez. Hold on. This is terrible. Seltzer. All right. So, alka-seltzer and my water. Now, this is what you massed before. The tablet, the cap, the vial, the water. 56.38 grams. Afterward, you have less. Most people had about 1/10 of a gram less. Between 5/100ths and 1/10, almost everybody dropped. All but just a few. So, how do you explain that? Did you notice anything when the alka-seltzer tablet went in the water? What was that? Oh, you noticed some fizzing and bubbling? I hope that's just what you were thinking when I said that. So, there was some fizzing and bubbling going on here. Does anyone know? Well, the fizzing and bubbling is an indicator that what has happened. Does anyone know? A chemical reaction. So a chemical reaction, one of the evidences is fizzing and bubbling. So, and that's what we saw here. So there was a chemical reaction that took place. Now, did you see something produced? That there was something produced in this chemical reaction that was not there before? Huh? If there's fizzing and bubbling going on underwater, then what has been produced that wasn't already there? Yes, for those of you that are thinking it, it's a gas. Folks, a gas was produced by the alka-seltzer tablet combining with the water, and the fizzing and the bubbling, that's a gas. Now, is the alka-seltzer tablet still an alka-seltzer tablet in here? Well, I don't know. That's tough to say. Maybe there's a couple particles left of the original alka-seltzer tablet. Couple particles left. But there's something else now that there wasn't there before. So what is this something else we're talking about? Oh boy, folks. It's a gas, which means I have to add something else to my key. Now I have some gas in the water itself bubbling around. I have maybe some gas in the upper part outside of the liquid. And then, if you remember, the instructions were that you were supposed to leave the cap on loosely. What do you think happened to some of this gas? Yes, it got out, people. It got out. Some of the gas got out of the vial and went away. Okay? It went away. Some of the gas left. Okay? The gas left the vial, which did what? Oh, it dropped your mass. Why'd your mass go down? Because you lost some particles. You getting me here? You lost particles, mass went down. How did they get out? The gas got out. Ooh, yeah. Next. Okay, here we go. Now, I noticed a couple of people, there's not one of these in every class, but a couple people had the Alka-Seltzer numbers stay the same. How could your Alka-Seltzer numbers have stayed the same? Any thoughts or ideas on that? Well, I hope you're thinking what I'm thinking. Oh my gosh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I got that. Okay, now I gotta, oh no. Oh, you know what? This is good. I'm gonna draw my Alka-Seltzer tablet. No, that's not the Alka-Seltzer, it's red. The Alka-Seltzer tablet, I'm gonna draw in red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10 particles of Alka-Seltzer, and I have my water, my 15 of water, and then you put those together and they fizz and bubble and pop and whatever. If your mass does not go down, then everything that you started with, you have to end with. So how are you going to show that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, a couple of those got out of hand, a little big. So I still have my water particles. Now, are there a couple Alka-Seltzer particles still in here kind of floating around and not dissolved? Yeah, probably. You probably saw some white residue in the vial, and that could be some Alka-Seltzer left over that never dissolved. Okay, so I got a couple particles of that. We obviously said a gas was produced. 1, 2, 3, 4, 5, 6, 7, 8. Now, remember, I had 10 particles here, 15 particles here. Now I still have my 15 water particles. Then I have 2 Alka-Seltzer particles left. Then I have 1, 2, 3, 4, 5, 6, 7, 8 gas particles. 8 plus the 2 Alka-Seltzer particles is my 10 total over here. So what am I saying over here? I'm saying none of the gas got out. If my masses are the same, then none of the gas got out. If none of the gas got out, then what does that mean about the lid? It means you didn't follow directions and somebody put the lid on tight. So, people, if you screwed the lid on tight and you didn't let that gas out, then your mass is going to be the same. Okay? Are you following? Are you following the logic? I hope you're following the logic. All right, last one. Last one. Then there's going to be another video. Oh my gosh. Yeah, I'm not kidding. I'm not kidding. So, oh, here we go. All right, water again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, hey, by the way, a little pause here. Hey, are you all changing your particle diagrams to show what I'm describing here for your own data? Because let me tell you something. Some of your particle diagrams were terrible. So I hope you're following my lead here and changing and adding and taking away and whatever, editing your particle diagrams for this lab, because some of them were pitiful. All right, so back to the story. Let's see. Alka-Seltzer, hold on. Alka-Seltzer tablet, big old wedge there. And let's see if I can fit 10 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so I got 10 Alka-Seltzer particles. I have 15 water particles. Same old song and dance, same old thing. Now, if you notice here, the mass went up substantially here. Like almost 3 grams the mass went up. I wonder why. I wonder why the mass would go up like 3 grams almost. Well, let's see what happened here. So remember, we still have our water afterward. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 water particles. Are there a couple of Alka-Seltzer particles that are still in the water? Sure, I'm sure there are. Are there some gas particles out in the vial? I'm sure there are. Did some escape? I'm sure there did. If the lid was loose, I'm guessing that probably. Oh, wait a minute. Wait. Oh, there we go. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it. Okay. So this then would be what you had happen. If the lid was on loosely and you did everything as we had talked about, then some of the gas got out, some of the gas stayed in here. Oh, I didn't put any gas in the liquid. It's fine. I'm sure it's fine. The question is, how'd your mass go up by 3 grams almost? Well, I got an idea. Same thing that happened with the sugar. I'm pretty sure it happened a couple times here. Now, not in every class. Every class does not have one of these where the mass went up by 2 or 3 grams. But I did see a couple in there. So, what does that mean? I hope you're remembering what that means. That means somebody forgot to measure the alka-seltzer and the cap before for the measurement here. Then remember, the cap is 1.7 grams-ish, which means if the alka-seltzer is about 1.2 grams, then you're going to have an increase. Your mass is going to go up by almost 3 grams from before to after because you didn't mass some of the stuff that's in the after that wasn't massed in the before. Oh, jeez. So, I hope you've learned something here. I hope you've fixed your particle diagrams if you hadn't yet. If you hadn't fixed them by the end of this video, then go back and fix them right now. Get in your comp book, which should already be out right now, and fix your particle diagrams to match what your descriptions are saying. All right? Yeah, I think that's pretty much it. Goodbye. Have a great rest of your day.